Good morning and good afternoon, everyone. Welcome to today's webinar, Safe and Sustainable, Understanding the Biobased and Compostable Alternatives to Plastics in Food Packaging. We are very happy to have you with us today. My name is Etienne Caban. I am the Engagement Director at the Food Packaging Forum, and I am leading the Understanding Packaging Scorecard. I'm going to start us off with a few housekeeping items and then a short introduction to the Understanding Packaging Scorecard. So to tell you who we are and why we organized this webinar. And you will then hear our speakers' presentations, and we will keep some time towards the end for a Q&A session. Some housekeeping rules. So your microphones are muted, but you have the option to put your questions in the Q&A box at any time during the presentations. The Q&A box should be at the bottom right of your Zoom screen. Please note that this event is being recorded. We will share it post-event with everyone. I would now like to quickly introduce today's speakers, who will also present themselves when they get to their sections. Please note that their full bios can be found on the UP Scorecard website as well. So from left to right, we have Dorota Napierska. Dorota is the Toxic-Free Circular Economy Policy Officer at Zero Waste Europe. We have Lisa Zimmermann. She is a Scientific Communication Officer at the Food Packaging Forum. Matt Saunders is a venture capitalist investor at New Earth Ventures, which is the corporate venture arm of Atlantic Packaging. We then have Hoa Doan. Hoa is the Head of Impact and Sustainability at Notpla. And Marissa Schwinn. Marissa is the International Sales Manager for Traceless. So a very nice lineup today. And I'm going to have a quick look with you at the agenda for today's webinar. So I will, before our speakers dive into the topic, I will give you a short introduction to the Understanding Packaging Scorecard. And then you will hear the speakers' insights on different topics, regulatory situation in the EU, some definitions and challenges for bio-based and compostable materials. And finally, we are happy to have some guest speakers from the manufacturing side, from the industry, who will share guidelines and principles to assess the sustainability of these materials and provide other industry insights. And as mentioned before, we will finish with about 15 minutes time for questions, answers, and discussions on the topic. So let me start by giving you a few words on the UP Scorecard, the Understanding Packaging Scorecard. So this is an initiative from the Single-Use Material Decelerator Group that you can see on the left of the screen. The Single-Use Material Decelerator Group is a multi-stakeholder collaboration of food service industry professionals, scientists, and NGOs, with a shared vision of a world where food service providers and food brands use foodware and food packaging without negative impacts on human health and the environment. And when we started the journey and when we discussed the topic of food packaging sustainability with various stakeholders, we quickly realized that there were lots of difficult questions that were unanswered. And we realized that food packaging stakeholders needed science-based tools and guidance to answer these questions and to support their decision-making processes. So we figured out that there was a need to show impacts and trade-offs of different food packaging and foodware in a simple way. And this is how the idea of the Understanding Packaging Scorecard project started. So the Understanding Packaging Scorecard is a free, easy-to-use, science-based tool. It is meant to assess and to compare the sustainability impacts of common foodware and food packaging. And although it was initially designed to help procurement officers in the food service industry, we now work with various actors along the food packaging value chain. The tool lets you easily and transparently compare the environmental and health impacts of foodware and food packaging across 6 key science-based metrics. So this is a really holistic approach to sustainability with a set of metrics based on LCA, such as climate impact, water use, and plastic pollution, and a set of metrics covering circularity, sustainable sourcing, and recoverability, and one very specific metric that is unique to the Understanding Packaging Scorecard is our chemicals of concern metric that looks at the presence of harmful chemicals and how they can migrate into the packaging. In the tool, we have several items that are made of bio-based and or compostable materials, both polymers and fibers. So you can see on the screen we have bioplastics such as bio-PET or PLA. We have fiber-based materials such as paper, cardboard, or molded fiber. And if we have a closer look to, for instance, paper cup with a PLA lining, like other materials, you can see the results screen in the tool basically provides a score for all of the 6 metrics that we have been discussing. And it quickly shows the different trade-offs with these color-coded scores here. And we have a fine summary score, on the right to summarize the different metrics. Specifically for bio-based materials, you have also a few parameters that you can change in the tool and that will affect the score of these bio-based food packaging products. So on this next slide, you can see here if we model in the tool a sort of default paper cup with a PLA lining, with a given post-consumer recycled content, for instance, it doesn't have any certifications for the raw materials, fibers, and so on. In terms of recoverability, it cannot be recycled, and it doesn't have a composting certification, and it does not comply with our list of harmful chemicals, meaning that we either do not have information on what chemicals can be present in the material, or we know that there are some harmful chemicals in the material. And on the right, you can model a sort of best-in-class alternative, a paper cup with a PLA liner, but with better parameters. So we can, for instance, state in the tool that it is an FSC certified material, and we can add in the tool that it has a composting certification such as BPI, for instance, and you have the availability of the composting facilities to process this type of cups. And you can also, for instance, say that for sure that all the chemicals from tier 1, which is the prioritized tier, with all the chemicals that should be phased out from food packaging, you don't have any of these chemicals, so you can say this in the tool. And you can also specify the level of disclosure, for instance, a third-party verification. You will see on the next slide that this new best-in-class cup that I designed has a better score in several impact categories than the default paper cup. So you can really modelize in the tool. This is how we cover the assessment of bio-based and compostable food contact articles in the Understanding Packaging Scorecard. And with this, I'm done. I just want to tell you, if you want to learn more, you can visit our website. We've also designed a very new help guide to give you the basics on food packaging sustainability and to help you navigate in the tool and create scores in the tool. And of course, I invite you to explore the tool itself and go and do some assessment in the tool. So with this, I'm done, and I'm going to hand it over to Dorota. Dorota is going to give us her insights on current regulations for these materials in the EU. And Dorota, the floor is yours.
Thank you, Etienne. Hello, everyone. Just checking it's working. Okay. So again, hello, everyone. For those who don't know Zero Waste Europe. We are the European network of experts and organizations working towards better use of resources and prevention of waste in our society. And we actively work also on the integration of the principles of the bioeconomy, focusing on the utilizing of bio-waste as valuable resources. And the bio-based materials, which we're going to address today, are increasingly important element in the broader bioeconomy focus on biomass. So in the EU, we adopted the first bioeconomy strategy in 2012, and we updated in 2018, including also to support new EU policies, priorities at the time. But as sorry, I think I will have to use the mouse. Okay, not really working as fluently as I would wish to. Well, the EU policy priorities today has changed again. So we are actually expecting adoption of the new strategy by the end of this year. And the Commission is planning this new strategy to tap the significant growth potential of bio-based materials. Second, as I see some screen. So substituting basically fossil-based materials. And I would like just to also draw your attention that in fact there is a public consultation still open. The public consultation on this upcoming strategy, and everyone is really invited, so both from and outside the EU, to share valuable feedback, insights and information with the Commission. So actually there's the link to this consultation can be found on this slide. And now zooming a little bit more on the topic of today's webinar and safety of the bio-based materials that are used in food packaging. So in the EU, they are, as all food contact materials, covered by a legal definition in so-called EU FCM framework regulation. And this definition is basically saying that all materials under a normal condition of use should not transfer their constituents to food in quantities which could endanger human health. But unfortunately, this rule is a bit too general, really, to conclude on how the safety has to be achieved and how it has to be demonstrated. And actually, if this definition originates without any change from a really old FCM directive from 1976, so it's almost 50 years old. And also, even against policy-making norm in the EU, the food contact materials regulation has not been revised since the entered into the force in 2004. Also, really important is the fact that we are also missing, the harmonized rules for majority of materials actually used in food contact material in food packaging. So now, looking at the EU policy agenda that is relevant for safe and sustainable food packaging, packaging missed, sorry, from the slide. So it's also relevant, of course, for all bio-based materials. After adopting between 2018 and 2020 number of EU strategy on plastics, on production of food and chemicals, and also introducing the important single-use plastic directive, which introduced ban on certain single-use plastic food packaging, and as well as mandatory recycled content in PET beverage bottles. We have at the end of 2020 finally the revision of those regulations I mentioned before, so food contact materials framework regulation kicked off. And in June 2020, the official and a comprehensive evaluation of this regulation has been completed, pointing actually to many deficiencies and shortcomings identified. But unfortunately, the revision has been still facing a lot of delays. So today it's very difficult to say when we actually will see this revised proposal of the new law. One of the obvious reasons can be that the Commission spent also time and resources to work on other pieces of legislation. So since 2022, we have in the EU completely new regulation bringing rules of recycling of plastics into food contact materials. And in December last year, we have also the new regulation banning bisphenol A and some other bisphenols in food contact materials, of course, also in food packaging. And then this year, since this year, we have the new really important piece of legislation, so covering all the packaging waste. And this is very big and complicated law, and there is no time really to go into details, but it's important to know that it's bringing a lot of new rules for packaging, including food packaging. Those rules are covering more like sustainability of packaging solutions, and they also address biobased and biodegradable plastics and compostable packaging. They introduce ban on PFAS in food packaging. They also, this legislation brings targets for recycled contact and plastic packaging, targets for reusable, refillable packaging. There's also the plan for ECHA, so European Chemical Agency, to prepare like a really detailed mapping of so-called substance of concern. This report should be published by the end of the next year. And finally, also this year, we have a new regulation that is amending a couple of different regulations, but basically important for this particular topic. It addresses also specifically biological or natural origin substances used in plastics, and it brings also some other stricter requirements for plastic food contact materials. So basically, if you look at the slide, it's clear that a lot of work has been focused on plastics, and also this new rule when it comes to safety is on plastics. But actually, when you look at what's going on the market, we see that there is a lot of packaging, food packaging solutions that are moving away from plastic. So here are just examples from the surveys made on the market in the Netherlands and Belgium. And it's very clear that there's actually really like fiber-based solutions are replacing many plastic packaging. As you remember, I just mentioned a couple of slides ago. So that's just actually materials that are still missing, you know, the really like the harmonized EU rules. That is basically the conclusion will be from my presentation today will be that still as a matter of priority to truly ensure really safety of food packaging, including those that are bio-based, we really need a comprehensive revision of the food contact material regulation, and hopefully this revision should also bring new harmonized EU rules for all categories of food contact materials. Well, this is just the letter, just an example that we are also involved in. This is one of our initiatives. The letter was sent to the Commission in December last year, but was also co-signed and supported by many businesses in the in the EU, asking Commission to commit and to finalize the revision. And that's all from my side today. I just, of course, invite anyone who is interested to check in different resources we have on food packaging, recycling, and different aspects of, let's say, related to sustainability and safety. Thank you.
Thank you, Dorota, for this great presentation. And the clear overview of the regulatory challenges in the EU, highlighting the need to harmonize rules and showing that if we want to do things right, we need to consider new alternative materials in the ongoing FCM regulation revisions as well. I am now turning to Lisa, who will give us some definitions and the basics to understand specific challenges associated with bio-based and compostable FCMs. Lisa, over to you.
Perfect. Thanks a lot, Etienne, for your introduction. And I will be giving a short, I'm working at the Food Packaging Forum, and we are a foundation for science communication and scientific research, and we focus on chemicals and food contact materials and on the environmental impacts of food packaging. And one topic we are interested in is also bioplastics. And now you heard already a lot about bioplastics, but I want to take a step back and give you a short definition, since this term can be a bit misleading. It covers two different things, basically. On the one hand, it can refer to bio-based materials, which are made from renewable feedstock sources, such as sugarcane or corn. And on the other hand, it can refer to biodegradable materials, which are designed for microbial conversion into carbon dioxide, methane, biomass, and mineral salts. Compostable plastics are a subset of these biodegradable ones, and they typically decompose in industrial composting facilities. This means that not all bio-based plastics are biodegradable, and on the other hand, not all biodegradable plastics are bio-based nor compostable. Okay, but now let's dive into the topic. So usually newly developed bioplastics are commonly assessed according to sustainability and performance criteria, such as CO2 footprint, reduction of fossil resources, and litter, as well as timed degradability. However, chemicals in bioplastics and their safety, they mostly receive little attention. And therefore today I want to evaluate the questions, are bioplastics safe or are they safer than conventional plastics? And with conventional plastics, I mean petroleum-based, non-biodegradable ones. And as a point of reference, let's first have a look at conventional plastics before we are moving on to bioplastics. You may be aware that these plastics are chemically complex materials. They consist of monomers that are polymerized into branched interacting chains, and of additives, which are chemicals which are added to improve the material's properties and to widen the application. They include, for example, plasticizers, flame retardants, and antioxidants. And we know that more than 4,700 chemicals may be intentionally used in food contact plastics according to industry and regulatory inventories. On top of these chemicals, further substances are present non-intentionally, such as impurities of starting substances and breakdown products of additives. So, as you can see, plastics contain a wide range of synthetic chemicals. And what we also know is that hundreds of these plastic chemicals are of concern. So they are, for example, known to be carcinogenic, mutagenic, or toxic to reproduction, or to affect the endocrine system. And this is problematic since they can transfer or migrate from the food packaging into the food, making them available for human exposure. In fact, and that is also some work we've done at the Food Packaging Forum, we compiled the scientific evidence on the topic, and we found that scientific studies detected over 1,700 chemicals to migrate from plastic food contact articles into food or food simulants. Okay, that was a lot on conventional plastics, but let's move on to bioplastics. And here I quickly give you a little insight into my PhD, which is now a while ago, but here I analyzed the chemical composition and toxicity of 43 bio-based and/or biodegradable products, mainly food packaging. And what did we find? So looking at the chemical composition, we detected hundreds to thousands of chemical features in individual samples. And accordingly, bioplastics, just as conventional plastics, can contain a wide range of synthetic chemicals. And if you think about it, it makes also sense. Then, just as the case for conventional plastic, the manufacturing and functionality mostly depends on the addition of chemical additives. Furthermore, they may rely on synthetic polymers to be added and fillers. Some of them might even require more chemicals than conventional plastics to offset potential limitations inherent to these materials, such as brittleness or low gas barrier properties. And then for bio-based plastics, we might also still find pesticides and other chemicals applied in agriculture in there. And this might be the case, this might not be the case for all bioplastics, but they can be in there. But do these mixtures of chemicals contain also chemicals of concern? And to assess this, we extracted the chemicals contained in the 43 bioplastic products and applied them to different in vitro tests, meaning to cell-based assays. And here we found that 2/3 of the samples induced toxicity in our assays. And we compared these results to a previous studies which we performed with conventional plastics in exactly the same way. And here you can see the outcome for one of the endpoints, which was like a general or baseline toxicity, conventional plastics on the left, bioplastics on the right, and each dot represents one sample, so the chemicals contained in one bioplastic product, and the red line is their mean. And since this line is approximately at the same height, this indicates that conventional and bioplastics are similarly toxic. And what you can also see is that these dots are spread out, and this shows that these samples differ in their toxicity. There are some with more, which have a higher toxicity for this endpoint, and then there are some which are non-toxic. That, like looking at the other effects we were analyzing, we, for example, included estrogenicity and anti-androgenicity as two endocrine disrupting effects. And similarly, as seen for baseline toxicity, conventional plastic and bioplastics induce toxicity at a similar level. And this demonstrates that bio-based biodegradable materials can be as toxic as conventional plastics with regard to the chemicals that they contain. Our results were only were focusing on in vitro effects, but there have been also in vivo studies which found that bioplastics and their chemicals can adversely affect terrestrial ecosystems and organisms such as earthworms and mosquitoes, as well as marine and freshwater organisms, for example, mussels and sea urchin and many more. And one further aspect, which is also a kind of hot topic right now, is that besides chemicals, also small plastic particles can be released during the normal and intended use of plastic food packaging, such as tea brewing. And these so-called micro-nanoplastics can pose an additional safety challenge, and this is also the case for bioplastics. In fact, recent research shows that starch-based microplastics can have a widespread health effects on mice. So taken together, this demonstrates the importance of integrating safety and sustainability assessments. And only then it can be concluded if a certain product made of bioplastics is a promising alternative to conventional plastics or not. So if you want to read more, there is a fact sheet we published with the Food Packaging Forum. And if you're more interested into policy recommendations, you may also want to have a look at the policy brief, which we published with the Scientists Coalition to feed into the currently ongoing discussions of the Plastics Treaty. So to sum up, bioplastics can provide benefits over conventional plastics, such as the reduction of fossil carbon use. But just as conventional plastics, they can affect human and environmental health, for instance, since they are chemically complex materials, which can imply safety challenges. So therefore, when designing and evaluating potential sustainable alternatives to conventional plastics, it is key to consider safety as part of sustainability assessment. And yeah, with that, I hand over to Etienne.
Thank you, Lisa, for this great presentation. We'll just, yes. I think it was again very helpful to hear you summing up these main issues and challenges that we face with those kind of materials. And also, as you mentioned, the hot topic, interesting to hear about nano and microplastics, which represent another challenge. So now that we are all on the same page, thanks to our first two speakers, Matt Saunders is going to tell us about the challenges faced by the food packaging industry when trying to adopt new material options. So Matt, I will hand it to you now.
Thanks, Etienne, and hello everyone. Matt Saunders here, calling in from Atlantic Packaging's headquarters in Wilmington, North Carolina. It's great to be with you. Thank you for having me. Before I get started, though, I am focusing on the challenges in investing in alternative materials in food packaging. I just want to start out by saying that we are really excited about all of the innovators that are attempting to bring better new materials to the fold. And I think without the thoughtful, ideological, or economic-driven young people who are doing this, we won't get anywhere in terms of future packaging materials. So it's a hard road, it's challenging, but we're really, really excited about all the innovations coming from brand new materials, a new way of looking at our waste economy, and so forth. So thank you to everyone participating for everything that you're doing there. I want to introduce New Earth Ventures to start, which is Atlantic Packaging's venture arm. We're a hybrid corporate venture arm in the sense that we use all of the resources of Atlantic to support the companies that we invest in, but we do have an LP arm and solicit investments from a small group of limited partners. Atlantic Packaging is a leader in North America. It's almost 80 years old. It is the largest independently held packaging company in North America. And while we have a large footing here, we are helping customers' brands that are absolutely global. And our affiliation between New Earth and Atlantic Packaging is really how we're able to think about what the best companies to invest in are, how to support them, how to lead them through their growth, not only through our know-how, but our ability to test, our ability to scale, our ability to bring customers to the platform. And we're doing this type of investing across alternative materials and packaging and supply chain technologies writ large. And I am leading the efforts with Wes Carter, who's the president of Atlantic Packaging. We invest in, as I said, new materials, closed loops around eliminating waste, software, automation, and AI. I think people who have been able to integrate the tools the computers have given us to iterate in biomaterials, I think it's fascinating. There's so many other ways that these software tools can help manage exposure to chemical sustainability, what have you. So we're making a lot of strategic bets in the technology side of things, and then trying to rethink the supply chain. How do we make things more sustainable and better for us? Obviously, within the new materials segment is where we think about food packaging. And I generally think about food packaging in two ways. Primary food packaging, the stuff that's going to touch the food products itself, everything that Lisa was just speaking about. Ideally, we're focused on compostable food contact approved barriers, really thinking about how fiber-based packaging can replace plastic altogether. This means stand-up pouches, a lot of meat trays, and thinking deeply about shelf life enabled packaging. QSR is on there, but for us, it's not a huge focus. And then we think a lot about secondary packaging, which we think is frankly for food a lot easier because it's not touching the food directly. But focused a lot on the cold chain and thinking about compostability or curbside recyclability versus what's out there now. A switch from plastic to paper overwrap, and generally thinking about fiber-based packaging where plastic has been the lead for some time. Why are we doing this? There's the obvious impact angle, health being a big part of that, so it's natural that we come after Lisa. But getting rid of PFAS, understanding the endocrine disruptors, potential cancer-causing elements of plastic, we want to get rid of that. And obviously, the environmental impact. Packaging is 46% of plastic pollution. And as someone who has a foothold in packaging and can do something about that, we really want to change that. One thing I just want to show is an example. I don't know if it's going to work, but EPS foam, something that we see a lot in food packaging, especially around raw meat trays. It's something whose useful life is 5 days, but will stay in the environment for 500 plus years. If that doesn't tug at your heartstrings or make obvious the environmental impact, I don't know what will. But how can we change the way that we think about the single-use economy? It's a big part of what we focus on at New Earth Ventures. Why are we doing this part two? Well, across the world, there are regulations coming into be to really force people into, and by people, I really mean corporations, into introducing non-plastic based food packaging. UN Plastics Treaty is a big part of that. EPR laws, which are not new to most of the world, right? Europe, provinces in Canada have had EPR for some time, but is new in the United States, and will become a foothold, especially as it launches in Oregon and next California, one of the biggest economies in the world on its own. Regulations are coming. And so alternatives in food packaging need to be there to meet demand for all of these goods while being regulated. And I think third, what's really important here to know is that consumers are asking for different packaging, especially younger consumers. We think that there's a strong willingness to pay more. It's not much more, but it's there. And we see CEOs thinking about sustainability in a big part of their strategy to win over these consumers. So there is a lot of push into doing it, again, which is why we're excited about this generally, but there are a lot of challenges. I want to start with my high-level guiding principles in investing in this area. And the bar there is better. I think simply matching what else is in the market is going to be difficult. Net, new materials for packaging have to be better than the plastic already in the market. Now, that doesn't mean better in everything. I think that means weighing the areas in which you can be better. Obviously on price, we don't think there really is a desire to pay much more in much of the world. And that, price parity you can think about in a few ways. You can think about it 1-for-1 versus plastic. You can think about it on the total cost of ownership basis. When you add in EPR fees, which is helpful to alternatives, there is price parity with some alternatives now when you add in having to pay those fees. Performance parity, I think that's absolutely a must. And I think new materials have to be there or better. You have to have a better start of life and a better end of life story. And I think most crucially, this technology has to be able to run on the same infrastructure. We don't think that manufacturers are going to spend a significant sum of CapEx to change the machines that they have. That's both in creating the packaging and in actually putting food inside the packaging, sealing it, and moving it on. You need to be able to integrate into those means of production. And we think if companies are unable to, they will not win the day. So this is our bar. And I'll say that this bar in packaging is very high and it's hard. We've seen a ton of companies get there, Some of them are on this call. And I kind of want to talk about the themes or the areas that we're thinking about in food packaging, from closest to adoption to furthest from adoption. So generally in my closest to adoption realm, I think about 3 use cases. The first is secondary packaging, primarily because it's not touching food. There's a lower bar around safety. There are a lot of technologies in secondary packaging that can get really sustainable. And so what I'd say, if any producers are on the line, any manufacturers, any brands, drive towards secondary packaging. And if we can be helpful at Atlantic Packaging, we'd be happy to. After that, there are the QSR use cases and single use cases. And why do I talk about this first? I think these are closest to adoption because they don't need to stay on the shelf very long. The use case time is very low. Yes, there's a higher bar because of food contact, but the technical abilities of these packages don't need to be very high, right? QSR, you're going to a chain restaurant, or you're going to an event and you're getting something in a box, you're going to eat it, throw it in the trash. The use case time isn't very long. Now, it's important. You got to get safety, you got to get grease resistance, but we think that widespread adoption of alternatives there is close. We also see a lot of rigid single use, whether that be PLA or others. We look forward to PLA alternatives coming to market, especially cheaper than PLA. But there are a lot of folks working on this that we think are really close. But from an Atlantic standpoint, as I said, we're really focused on secondary packaging in this realm. In terms of the longest road to adoption, we're really focused on 3 areas in this market. The first is bio-based coatings. We have a deep thesis that to get rid of all of plastic in a CPG supply chain, we need to find an alternative barrier coating. We really would need that to transition away from plastic, outer wrap, pouches, so on and so forth. And we generally evaluate these coatings on 3 core principles. They need to be, have high mechanical, thermal, and barrier properties. They need to be able to be applied in existing manufacturing abilities, or in with very small, easy changes. And they need to be deeply sustainable, with an idea that generally we want bio-based and compostable. There are a lot of technical qualities here, but we're looking for bio-based coatings to meet WVTR, OTR, and grease barrier in terms of plastic. Once we hit that bar, we think we'll see a proliferation of bio-based materials. We also aren't exactly sure that one company will win the day. We think there's a strong chance that you have to group companies together. Number 2 is raw meat applications. It's really hard with the contamination effect to find a good recyclable alternative here. We really need a compostable alternative in the raw meat space. And we're deeply looking in this. This is really where our focus is right now at NEV and at Atlantic. And one thing that we think is way far out that will be interesting is liquid pouches. And folks all over the world are looking at sachets, but finding a bio-based compostable sachet that can have a long shelf life, deal with a different variety of liquids that may or may not be super acidic, that's going to be really hard, but we think that's the holy grail. I think one major problem with investing in this realm is that it's a fragmented market with many startups competing against each other. At the same time, there are many corporates in the kind of wider plastic realm that are attempting to compete with these startups and have significant assets to do so. They may or may not be more innovative. I'm not really ready to pick a winner, although I think that there are a ton of startups that are doing it differently than the corporate world, and I'm a huge fan of radical innovation. But because there are such high CapEx costs to developing a lot of these goods, because this is a high volume, low margin industry, we think investing in this area is really tough. And we think it takes a lot of money to get a winner to scale to be able to compete in the market. And then we can add a bunch of nonsense and good regulation is good. But here's an example of something that I think is really, really going to be a barrier to success, which is the compost problem in California. Right now, bioplastics do not fall under the definition of compostable in California because California is really trying to protect its organic composting industry, mostly because organic compost gets a lot more money than inorganic. And this worries us a lot because we think it'll stifle innovation. If you can't compost this packaging, all of these alternatives, there's not a huge market for it. We also think that as big corporations make decisions on their packaging, they're planning 3 to 4 years out based on legislation, regulation that's in existence today. We also think that it takes a great waste reduction strategy away. The best thing to do, as I said, on protein trays that need to be biodegradable, is to have compostable packaging, put all of your food waste in it, and send it to a composter. So there are going to be a lot of governmental, existential, regulatory risks to investing in this area. We think it's a major, major bump in the road, and we need to focus on things like this as a key strategy. At the end of the day, we really think picking a winner is difficult, and we hope we'll be able to do it. The reason we think we'll be able to do it is because we have the know-how, scaling capabilities, and customers to deliver returns. And because we have all of that ourselves, we think scaling with Atlantic or NEV as your partner is a lot cheaper, is a lot quicker. I'm not saying that Atlantic is the only one who's going to be able to do this, but I think that we're in the age of partnership. And so I would encourage anyone investing in technologies or trying to build a platform for alternative food packaging to call us. We have a unique platform that drives our intelligence and know-how, our innate diligence capabilities, our testing scaling assets, our legacy customer pipeline and ability to guide a go-to-market, and then a huge, unique, mature marketing strategy. But I'm very encouraged by the people working on this, and I am excited to see where you go. And hopefully, NEV or Atlantic can be a partner in your growth. So thank you guys for having me today, and look forward to further conversations.
Thank you, Matt. I'm just giving this here. Thank you, Matt, for this industry perspective. I think also showing us that there are many requirements next to sustainability to take into account for innovative food packaging materials. And I think this is a perfect introduction to our next two speakers, who are representing companies manufacturing innovative bio-based materials. So we will start with Hoa from the UK-based Notpla. And Hoa, the floor is yours.
Thank you for having me, and hello everyone. My name is Hoa, and I'm the head of impact and sustainability at Notpla. And we are a material science company based in London, UK, and we work with seaweed and plant to replace plastic from packaging material. So our hero material is seaweed. There's about 12,000 species of seaweed out there. A lot of these, as we found out over the years of exploring these wonders in the sea, is that they actually have a lot of properties that mimic the packaging properties that we can use. And what we use here, so there are two types of seaweed, the red seaweed and brown seaweed. You can find them really all over the world, over the coastlines, France, Spain, Scotland, there's also a massive seaweed industry in East Asia as well. And really, with each of these type of seaweed then brings different properties. So from being water soluble, heat sealable, to actually providing really great oil barrier, and can be made into flexible films as well. So what we use here is seaweed extract, which is flavorless, doesn't have any color or odor, and is stable when in powder form, shelf life. For some of our products, we also use the seaweed byproducts, which is seaweed fiber, and that is where we added them to make our seaweed paper. But just to show you, there are these are the type of products that are either on market or we are working on. So from seaweed coating for food containers to energy gel pots, where this is applications where we actually can eat the packaging, ice cream spoons, and also excitingly, we are working on flexible films as well. So seaweed is actually used in a lot of applications, and I can guarantee that you probably have consumed or touched or used seaweed extract already today. It is widely used in food, pharmaceutical, and cosmetic. And the seaweed extract that we use is actually a food-grade ingredient, and that's why a lot of our application, we actually design them so that they can be edible, so it ended up with being no waste. And that is really some of our proof points around a lot of the previous speakers talking about the concerns around chemicals within plastics, within bioplastic even. And really what Notpla set out to do is we want to be able to make packaging without needing to use these harmful chemicals. So our coating, for example, is able to replace PFAS in food contact materials. And a lot of our applications are really using only food ingredients, not even just packaging materials. And here are the three pillars when we think about how do we create Notpla materials, and how and why do we do it. So first of all, it's around sustainable sourcing. We don't want to just simply replace one ingredient with the next, but we want to make sure that the ingredient that we use are renewable and have low impact. So this is why we use seaweed, because seaweed itself has been known to be very regenerative, grow very quickly, as well as doesn't require any land use, fertilizer or fresh waters, and that's going to reflect on the life cycle of the entire products as well. And also, I think all the speaker mentions end of life. Really for us, we create packaging materials that have a wide range of end-of-life options. For paper-based products, we want our coating to enable paper recycling so that it doesn't have any chemical or plastic contaminations. All of our products are home compostable, as well as having redesigning products with the edible application in mind so that you reduce waste. And all of this then come down to the very low life cycle impact of our materials. In our LCA of our food container, we find that we are about 80% lower carbon footprints than plastic. And even with products that have very little plastic content, like a PLA liner, we are still about 40% lower in terms of carbon footprint. This is because from the start, from the sourcings of our low impact inputs to the end of life, where we remove all the risk of persistence and toxic chemicals in the disposal of our products. And just to say, we are not alone. There's a lot of exciting innovations going in this place. We are one of the founding members of the Natural Polymers Group. So all of the companies you're seeing on here, and including Saunders, who's one of the speakers today, are really working on the same, which we are working with only natural polymers. We don't chemically modify them. And we're working on these type of materials to replace plastic and other chemicals in packaging. And really, this is a growing industry and a growing category of materials. And the group here is to really support policies and legislations that really be able to bring these solutions to scale. And yeah, if please feel free to get in touch if you have any questions about materials or interested in supporting the Natural Polymers Group as well.
Thank you, Hoa. Thanks a lot for this presentation. Thanks for the insights on seaweed and its potential for various applications, as we have seen, including edible packaging. I think on one of the last slides, you've mentioned the Natural Polymer Group, and we are happy to have another member of that group with us today from Traceless. So I will now hand it over to you, Marissa, for our last presentation today.
Thank you very much. So I'm taking over. No, sorry, took a while. Okay. So, okay, I'm skipping the first slide, apparently. So, hi, my name is Marissa. I'm very happy to be here as well. As Etienne said earlier, I'm sales manager and also project lead for the paper packaging solutions at Traceless. And as Hoa also said, we are also a part of the Natural Polymer Group and also developing an alternative to plastic for the packaging solutions with positive impacts. So, which also goes in line to our vision. So why are we here? It's we really want to create a world without pollution and waste. And that's what we are doing that by developing materials that have a positive impact on the planet by making pollution history. But first, when we're now looking at where do we come from, I don't want to really run down on bring down the mood or so, but I think all of us know the numbers some way or another. We have a large effect of plastic in the world. So be it the microplastics that are seeped into the environment or the microplastic being consumed by us and end up in the body because of what we are eating from the food packaging and so on, or also the topic of PFAS, which we touched earlier in other presentations as well. So consumers, industries, and also politicians are asking for alternative solutions. And for looking for those alternative solutions, we have to change our mindset. So we have to look at doing not less bad, but really doing good. What does that mean? It means that if it's not about reducing by 10% plastic, but really designing a material that eliminates the term waste and adding valuable resources to the packaging concept. And that's a concept known as cradle to cradle. And here we design products that use healthy materials and that can also be fully recovered within the circle. So we don't, without any quality loss. So we don't recycle, but we're really thinking in circles. So the material recovers and covers and covers again. And for that, and then we go also, that also goes very well in line for the safety and hazardous or not hazardous ingredients. We take, or this concept takes the positively defined materials. So these materials are intentionally selected based on their safety, renewability, and recyclability or compostability. So it's not about just including or not knowing what is not included, but really knowing what's included and also not replacing just something by another chemical, but really knowing what you put in there based on these positively defined materials definitions. And by that you get a product or a packaging that is fully recyclable and compostable and does also protect the consumer health by design. And that's a concept that is that the whole of Traceless was really built around of. And so for that, we also looked at nature, because there is no waste in nature. It always recovers. And that's where we got the inspiration from for making our materials and for also taking our guidelines. So what we're doing is we use leftovers from the agricultural industry and we extract what we need out of it. So and then we have these pellets, and these pellets are thermoplastic and can be converted in the classical, typical, like Matt said earlier on, converting machineries or machines, and for example, for paper coating, so that we get barrier properties for the paper, or also heat sealability, as well as, for example, these items such as cutlery or also films. And then, like I said, we don't think in the technical circle where we think in recyclability, but really think in for the traces material in compostability. So it's really, it can be recovered by nature. We give back what we took out of nature, and it can be used as nutritions. Of course, at the same time, paper is recyclable, so we don't stop the recycling process there at that end. And since we are now coming back to the positively defined materials now, what also goes very well in line, I think, also with what Notpla is doing. We have very, very strict principles of for our development. So there is no chemically modified polymer in our material. We just take the natural polymers. We don't take any toxins in there. So there is no PFAS, no heavy metals, no hazardous chemicals in our material. Of course, it's food safe. I mean, that goes without saying. And at the same time, we don't use any fossil-based materials. So it's 100% bio-based content that is in our material. And also by that, it is also biodegradable and home compostable. So it really does not do any harm. Even if it ends up in the nature, it does not do any harm. And then, of course, it's plastic free. Like I said before, we don't have any microplastic residues or whatsoever in the material. So we only use these materials. We only use ingredients for the development of a material according to these guidelines, which of course is a large challenge as well, because we're doing something that nobody has been done before. We don't use the chemicals we've been using for the last 70 years when we're developing plastic, but it's really a challenge we are taking on because we are really driven by this concept and in the belief that this is the only way how you design a product and a material nowadays. And this is also something that we have certified. So we are certified home compostable, we are 100% plastic free and also 100% bio-based content. And of course, like I said before, we are food safe. So yeah, that's already my last slide. So if you're interested in our material for some kind of packaging, I'd be happy to get in touch. Yeah, and then you can be part of the solution.
Thanks a lot, Marissa, for your presentation. Thanks for introducing this simple concept of positively defined materials. I think quoting you, and it also echoes what Matt was saying before. I think we can briefly conclude and agree that it is time to do good and not only less bad. So do better. We have a few minutes left for the Q&A the Q&A session, sorry. And we would love to hear about if you have any questions about the different concepts and information that we have been sharing with you. So please remember you can use the Q&A box to ask your questions. And without waiting too much, I will start with the first question. So it's a question I think maybe general and for the industry speakers that we have here, which basically is so are manufacturers assessing the presence and the migration of potential allergens in bio-based food packaging? So I don't know if anyone wants to answer that particular question from the industry.
From our side, we do, and actually seaweed is not food allergen. So, but as part of our process and in all the ingredients that we use, we always would be in conversation with the food safety standards. For example, especially for actually edible application is one of the key parts of the work that we do.
We get the question more and more as we look at alternative materials. We've been spending time around an alternative material that uses chitin, which is derived from shrimp, crab, other shells. People are really thoughtful about whether that's an allergen for people allergic to shellfish. So it's thought about. What I'd say is we see a shift right now in the industry towards technologies that are tracking this. So when people, when corporations are really working on developing a new product, what allergens are there and trying to stay away from those as much as possible. For the people who are the most technologically savvy, they're tracking those specifications and dealing with them in the early days and trying to design away from them. But this is a topic we hear quite a bit.
Thank you for these answers, Matt and Hoa. There is another question for you, Matt. How do you address the question whether the additives in your packaging are completely degradable or compostable to avoid accumulation of additives in the compost?
So the first thing I'll say is I am not the compost expert. On my team, we have a director of sustainability, Caroline Deloach, who is quite the star in our industry, and knows her stuff. So I rely on her entirely. What I'd say is the most difficult thing around compostability when it comes to an investing side is really that there are so many different formulations out there, and startups iterate. You know, lean startup is a big part of my philosophy, to get something into the hands of consumers, to see what they like, to iterate and make it better. Well, it takes a long time to get a compostable certification for BPI or similar. So picking the winner there is really tough. You want to design for home compostability. You want to design for complete degradation. And what that means is really desiring safe bio-based materials in the inputs. And generally when you do that, you'll be safe on the other end, but it's hard to invest in a compostable solution because a lot of times when you're investing, you won't know.
Okay, thank you, Matt. I think you went on mute at some point, but I think you're done. Yeah. Please, the other speakers, if you want to also contribute, just go ahead. Otherwise, we do have one question on a new material that comes on the market called Quartzo, which is silica-based lining for paper products, I understand. And it's a general question to the panelists to know whether we have information on the impacts of this particular material that might be used by big companies for coffee cups, for instance. So there is a specific question to, for instance, I don't know, Lisa, did the Food Packaging Forum evaluate this particular material already?
So I can keep it short. No, we didn't evaluate it. And yeah, actually, we don't do tests here. So I used to do them during my PhD, but it would be very nice if someone is in the audience who can have a look at it. I would be happy to see the results.
Thank you, Lisa. I will move on with one question, which I think is for Hoa. Is seaweed purposefully farmed as feedstock, and what are the environmental impacts?
Yeah, so there's currently the seaweed that we use is beach cast. So naturally, as seaweed fall and come on shore, it is being collected dry and made into extracts. But we also work with a number of seaweed farms as well. So seaweed cultivation in itself, we see that as in a large volume could be more efficient and actually could be more environmentally friendly, because you can then be able to control the conditions and the harvesting times of it as well. What we're currently working in-house is looking at a process of certifications for seaweed farming. Seaweed extract is already used in a lot of industry already, but I think the questions around sustainability is not at the forefront in those applications. Whereas for us, it is one of the key criteria that we work with. So we have an in-house team that looking at what are some of the criteria that we want to look at for a seaweed farm to be sustainable, what frequency of harvesting that would be needed. So it's something that we are working on, and we talk to people like the WWF, for example, who have done some of these assessment and work in other industry and learning from existing industry like the forestry industry as well, for example, to see as the category grow, how we can set better industry standard for the input materials as well.
Thank you, Hoa, for this answer. Maybe one tough question again for you, Hoa, and for you, Marissa. How do you ensure that your products are non-toxic? Obviously, there are provisions under the FCM legislation, though those have not prevented plastics to contain toxins. So how, on top of FCM approval tests, do you ensure zero toxicity?
Well, we have, maybe I can go on first. We have a flow chart, a flow diagram more or less, where there's really a threshold of what we define as ingredient or as additive that we can use, and that goes far beyond the food safety dimension. So it's really about that we are evaluating every single additive based on that is natural polymers, that is it is not hazardous, it's not toxic, that is basically coming from nature and not being chemically made for being an additive. And that's how we ensure that that it's really not toxic free, aside from the FCA guidelines.
And very similarly to us as well, even when we get our products tested, for example, to prove that we don't contain any PFAS, we will send our finished products to be tested and specifically require a very, very low limit to our test. It is about 5,000 times lower than the current limit for PFAS testing in the UK and in the US as well. So yeah, for us, we hold ourselves accountable, and because we control the inputs and the manufacturing process, we able to really know what is put in our finished products.
Thank you, Hoa. I think we will take maybe one last question, and I will try to combine two questions that we received that are basically related to the consumer behavior. And it's asking, so how do we make sure basically that the consumer is aware of the compostability of a certain type of packaging and will correctly sort it out after its usage?
So from our side, I think there has been quite a lot of study around labeling of packaging materials and how to improve recycling. Really, when we work with quite a lot of big venues like stadiums, where we actually even bring in our design team to design the bin with the Notpla logos of Notpla products, to really provide very clear instructions of where our products go. So, and we talk to a lot of waste managers as well, in making sure that our products go to the desired endpoint. It's a very labor-intensive process, but to us, I think it's we we're very happy to kind of provide that kind of advice and services to all of our clients, because it is very important to us that the products can find a second life and get composted correctly as well.
Yeah, that goes in line also with us. We're really very much in contact with the regulations and all that, so to make sure that consumers get aware of it, and also politicians and so on, so that regulations are adapted. And also that, of course, we are labeling the products and so on, because that's also the benefit for the brand owners or whoever is using them and putting them in the market, to really say it's a different material than plastic, so that that we are really labeling what the end of life scenario is. And also, I think what's very essential to understand is that Notpla, as well as Traceless and all the other natural polymers, they are different to the plastics, so they don't do any harm in that sense as they do as plastic does, for example. So, for example, for Traceless, even if it ends up in the plastic bin, then it doesn't cause any harm because it gets sorted out and is burned. But because it is detected as not plastic, but as it is not fossil-based, it doesn't add any CO2 emissions and so on, because of the material is plant-based. It doesn't add to the environment, CO2 to the environment. So I think, and that's really a change of mindset as well. Of course, we want to have it recycled in a proper way, but even if it does end up where it is not supposed to be, then it doesn't cause as much harm as regular plastic, because it's bio-based.
Thank you, Marissa, for this answer as well. I think we are running towards the end. So before maybe closing this webinar, we would love to hear from you about topics that would be of interest for a future webinar. So I'm just going to run a poll for a few seconds and give you the time to answer, to join. Yeah. So the question is, what topic would be of interest for you for a future webinar on food packaging? Obviously, sustainability of food packaging. We've proposed a few topics already, but feel free to think about other topics which you can answer below. You can put your answer below. So I'll give it another 10-15 seconds. So answers continue to come, but clearly I can see that reusable packaging is something that you would like to hear about. And then I think maybe we have to invite you again, Dorota, because food contact material regulations are also of high interest. Thanks a lot. I will close the poll now. Thanks for participating, and we'll get back to you. So I think this is the end of our webinar. Thanks for staying with us. We will be following up with the recording and with any questions that we were not able to get to today. I think there are some that we could not answer. Thank you everyone for joining us. We hope you found the information useful. Thanks, of course, to all speakers for their excellent presentations. And we will do a follow-up email with the recording. Feel free to follow up with any questions you have after that, and have a great day.